I can have a quick +1 in the chat if I'm visible as well as equally audible. Then we would start. Let me open my preview. Just a sec. The question of today is very interesting, and I kind of love this question. Start. Yep. So Namanjan has a query of can you provide Java solution using Dijkstra algorithm for this question, like moving in all four direction and getting minimum sum? Yes, I would. Why not? Okay. Today we have a very interesting question, I must say. Let me connect my pen tab. Just one more sec. Okay, good to go. Okay. So today's question was, hey, I am Siddharth. I'm a 5-star rated coder at CodeChef, expert at Code Forces. I would be your mentor for today. So today we would be doing the question of minimum cost path. Okay. And it has a hard tag, and the solve percentage is around 50%. Okay. And the next thing is that the company tags. Company tags are Goldman Sachs, Make My Trip, Samsung, Amazon, and Microsoft. If you are preparing for coding interviews, this question is kind of must. Why this question is kind of must? Because graph algorithms play a very important role, and this question has been asked in 5 big tech companies. So I consider this question absolutely very important. Okay. So let us move to the question itself. So we are given a square grid of size n, each cell of which contains an integer cost which represent a cost to traverse through the cell. We need to find a path from top left cell to bottom right cell by which the total cost incurred is minimum. Okay. From the cell ij, we can go from this side, this side, this side, and this side. How I am telling in all four direction, I would be telling you. Okay. Suppose this is the 0, 0. Okay. So if we go on this direction, this x value would increase. Okay. If we go on this direction, one value would increase. If we go on that direction, this side value x would increase. If we go on this direction, y would increase, y would decrease, x, y decrease. So we can see the same thing. Once y is decreasing, once y is increasing. One x-axis is decreasing, once y-axis is decreasing. Okay, x-axis is decreasing. So it means that we can move in all the four directions. Okay. Now what the question is next trying to tell us, understand the question very minutely, then you would see that how the question can be solved. Okay. So you are given a grid. Okay. And next you need to traverse through the cell. Okay. And the cost incurred is the cost at that particular position. Okay. Now, suppose the grid is 949. Suppose this grid is this one. Okay. So the minimum path from the cell 11 to NN is this path. Why this is minimum? You can see it. Okay. Because explaining this would be a tough task. Okay. Next thing is that this one. Okay. So this is it. So, but the main thing is that if you have solved that question or not, I don't know. But the thing is that if there is one more variation to this question, which is the variation to this question, you can move in only two directions, either this side or this side. Did any of you solve this type of question that you can solve in two directions, just two directions? Any of you solve this question? Can I have a quick +1 in the chat who all solved this kind of question that you can move in two direction, either two direction. Okay. This is the question of four direction, but anyone solved this question of two direction? Can I have a quick +1 in the chat so that I know which kind of audience I am teaching? Let me see the frame drop. frame drop is kind of less. Can I have a quick plus one in the chat? Okay. I don't think any of you solved because there is no plus one in the chat. Okay. So moving forward, if there was a question of moving in only two direction, then what we had done, I would be showing you. Okay. We had used DP. How DP? I would be showing you. I would be going from this direction to this direction and I would be comparing. And same thing after coming this direction, I would be making the minimum cost. And then I would again go from this direction and this direction. Okay. So what we are doing is first we are taking the first point. So we know that coming to this point, the minimum cost is this point plus this point. I would be showing you. Suppose this is a cost, this is a cost, this is a cost, this is a cost. So I know that the cost of this point is the value of this point, and the cost to come at this point is the value of this point itself. Okay, and the cost of this point is same thing. So this would be the base case, and the cost of coming in this point is the minimum of this cost or this cost, this or this. So we can simply use a DP itself. This would be the base condition and this would be the normal transition. Okay, I think I am clear with this. But in the case of four direction, so I assume that if you are, sorry, okay, so I assume that if you have came this far, like I was thinking really like go in that direction, which is the minimum at each point. Yeah, it is kind of correct. But the thing is that the constraint is the main part. Okay, the constraint is 10 to the power. The constraint is I think 10 to the power 3 itself. So this is the matrix. Okay, I am telling you why your approach won't work. So value of n would be from 0, 1 to 10 to the power 3 itself. Okay, so we would take the upper bound 10 to the power 3. As this is a matrix, so iterating on whole of the matrix would take n square iterations. Good to go. And then what we are doing is we are squaring it. Bases are same, so the value would be 10 to the power 6 itself. So we can afford a 10 to the power 6. So if you go on all the four direction, you would be taking four steps: left, right, down, up. Four states. Four states means n to the n to the power 8 because n square to the power 8. So am I clear with this? Why your greedy approach won't work? It would give you a TLE. Am I clear with this or not? Just tell me till this point. Okay. As the viewer count is very less, I would have waited, but the viewer count is so less, so I don't think waiting would be a useful effort. Okay, so moving forward, so that won't pass. Okay, so we need to think about something else. So whenever we have, suppose whenever you think about shortest path, okay, whenever you think about shortest path, okay, and suppose this is a graph itself. Okay, this is a graph. Okay, so when all the weights are same, what is the thing is that when all weights are same, you would be using BFS. When all same, okay, when all the weights are same. Okay, the next thing is that when the weights are different, and you need to use single source shortest path, you would be using Dijkstra. Okay, you would be using Dijkstra itself. Dijkstra is weights are different. Okay, so now you would be telling that how are you telling this? So this is not very trivial to tell you this. So it is a kind of that we generally build a vocabulary. What a kind of vocabulary? Like if we want to search an element in an array in a short period of time, we use, if the array is sorted, we use binary search. So this is an unsaid rule that we would be using that kind of thing. If we want to sort at every iteration, then what we use priority queue. So by coding and doing all this programming and stuff, that is why most of the experienced people, when you ask from tips from experienced people, they tell you that do practice. Why do practice? Because then you would build a vocabulary by yourself. What kind of vocabulary? Like when to do what. When to do what, you would build a vocabulary like this. Like you would build a vocabulary that when the weights are same, I would be using BFS. When the weights are different, I am using Dijkstra. Now why I'm exaggerating so much on this? Because the thing is that it might be the case that this kind of question won't come, but a variation would come, and it is the common practice. So if a variation comes, don't if a variation comes and you have learned the predefined solution to this, don't you think that you would fail in that situation? That's why I always try to tell you approaches which would be a generalized one. Like if you solve this kind of question, then you would be able to solve a question which is akin to this. Okay, too much of this, I don't think more is required. So now to solve this question, Dijkstra is to be learned. Okay, now Dijkstra has become a prerequisite of this. Now I would have explained Dijkstra, but as the time is from 3 to 4 p.m., it would be exceeded. Okay, because showing you Dijkstra, showing you the code, and then explaining this question would be a difficult task. Okay, how can you use Dijkstra? Like this one, you can solve this part. Dijkstra is a algorithm to tell you shortest path algorithm for different weightage. Okay, so good to go. Now where would you learn Dijkstra? If I am teaching it, I have already added the video link of the description, and in the description itself there is a Dijkstra. There is a link of the video of a YouTube which is completely free and is taught by Sandeep sir himself. And to be honest, I learned from him only. Okay, so I completely admire his way of teaching. Okay, and he is a god level coder. Okay, superb. Okay, so you should absolutely, if you don't know Dijkstra, then consider seeing that video, pause at this point, and then consider seeing that and then come back. Okay, now I assume that now you have learned Dijkstra. Okay, the prerequisite are already done. Okay, prerequisite is already done. Now I assume that you have already have a basic understanding of Dijkstra. You know the basic code. Now we would be trying to implement it, or now we would try to implement Dijkstra on this question to solve this kind of question. Good to go. Moving forward. Okay. So I assume that you have already learned Dijkstra. So moving forward. So first thing, the Dijkstra tells us that we would be initializing the distance with the maximum possible. Okay, and then we would be relaxing it. Now what do you mean by relaxing? Relaxing means, suppose the distance is 10 rupees. Okay, suppose the cost is 10 rupees, and if we have found a cost which is less than 10, then we would be doing that only. So it is like doing grocery shopping. That some, suppose you talk to a shopkeeper, he told you that he would give you in 10 rupees, and you have another shopkeeper who can give you in 8 rupees. So you would definitely go to the cheaper one. Okay, because you want the minimum cost. That is the thing. So same thing would be done. So at first I would be initializing the path with the maximum possible, maximum value, and then the thing is that I would be relaxing it. What do you mean by relaxing? I would be making it less. Okay, moving ahead. Now the next thing we would do is we would mark all the nodes visited as false itself. Okay. Now this problem directly uses Dijkstra. So we would be doing this. So what I did was, if I show you the whole code, I have the whole code written, but if I show you the whole code all at once, you would be saying that this is so difficult. So what I did was, I broke my code into small segments, and I would be explaining you each segment. Okay, why I am doing this and what I am doing this, so that you won't, so that it won't seem difficult, but you would be able to do an interesting question. Good to go. So moving forward, but the first thing that we would be doing is, as I said, first is like relaxing. Okay, what is relaxing? I would be making a visited array of 505. Okay, now the next thing is that I would be memsetting. What is memset? Memset is to make all the values to a particular value, 0 and -1. So I made it 0. What is 0? 0 means it is not visited. Okay, then what I am doing is I have initialized a value known as distance. Okay, distance means here cost itself. Okay, and I made the distance, every distance as the maximum possible, which is 10 to the power 8 itself. Okay, let me change this, 10 to the power 8 itself. Good to go. So the next thing is that the first thing, suppose 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 this is a graph itself. Okay, so this cost is 5. So what would be the minimum cost to visit this? The minimum cost to visit this would be the value at that point, no doubt, because there is no minimum, no maximum. It would be predefined. That's why I am assigning the predefined value with the normal one. Okay, the original one answer. So it is just like the base case, kind of base case. So what we are doing is we are on the first position and told that cost itself. Okay, moving forward. Now, what we are doing is, now we are, this is a, I'm extremely sorry. Let me build a matrix. So suppose the case is that at first I sit here. Okay, at first I sit here. So it is told that I can move in all the four directions, but within the grid. I need to be within the grid. Okay, the thing is that I can move in this direction, I can move in only this direction if that is the corner element. Okay, now suppose I am sitting at this position. Okay, so I can move in this direction, I can move in this direction, I can move in this direction, but I can't move in this direction, I can't move this direction, I can't move this direction. So it is said that we can move in all the four directions, but we need to remember that there is a grid and we need to be inside that grid only. Okay, like a boundary. We need to respect that boundary. Okay, suppose this is the value. So we can move here, we can move all the four direction, but in that case, corner ones, we can't move in all the four direction. Okay, we can't move it. Okay, so we need to respect the boundaries. How can we respect the boundaries? So suppose the size is, so 1 2 3 4 5 6 7. Okay, so 7. So what we can do is, suppose this is 7 by 7. It is not 7 by 7. 1 2 3 4 5 6 7. Okay, sorry, it is absolutely great. Unconsciously I made it, but this is a matrix of 7 cross 7. Okay, suppose the value of this address is 0 comma 0, 0 comma 0. So what I can do is I can see that from that position, if I go to the next position, before moving on to the next position, I need to check if that is within that boundary or not, if that is within that boundary or not. This is to be checked. Now how do I check that? Okay, I check that by using a simple function. Okay, that if I is less than 0, that means it is outside this boundary. I is greater than n, because it means that it is this kind of boundary. J is less than n, this kind of, this kind of. So if any of this condition is true, this would return false, else this would return true. So am I clear with this? This is a very small utility function, but it would help a lot. It would help a lot. Always you don't need to check this. You can directly give it the values and tell him that it is true or not. If the position I am about to visit is true or not, I can visit it or not. Am I clear with this or not? Just can I have a quick +1 in the chat, because this is important and the viewer count has now increased. So can I have a quick +1 in the chat? Please. A kind of small request. Please. I am trying to do my level best. So at least if you reply, it would be a very big reward to me. Okay. Moving forward. Okay, I don't think. Okay. The next thing is that, next thing which needs to be explained is that I would be relaxing every point. Okay. Dijkstra means, what does Dijkstra means? Okay. Dijkstra means, suppose this is a graph itself. Suppose this is a graph itself. Okay. Now what I would be doing is, I would be trying to relax that point. Relax that point to which point? To the minimum cost, with the minimum cost. So I would be using priority queue. Priority queue. Now you would be telling how to do this. I think you have already known this, because I assume that you have already watched that video in the description itself. Okay. Thank you. Moving forward. So I would be using a priority queue here. But I would be customizing that priority queue so that it would produce, so that the top one would produce me, the top one would keep the cost of the path which has the minimum cost. Okay. So suppose the costs are 10, 3, 5. Okay. So the priority queue would keep like this: 3, 5 and 10. The priority queue would be keeping like this. Okay. Moving forward. So this is how. So what I am doing is, priority queue pair of int and int. What is pair of int and int? This would store pair of int, comma, pair of int. This is known as nesting of the pair. Okay. So what I would store is, I would be telling you, I would be storing x-axis and y-axis and then the cost. That is how I would be storing it. So x-axis, y-axis, and this would be the cost. Okay. So what is the location of x-axis? How can I locate x-axis? X-axis can be located as ff first, dot first. Okay. Y-axis can be located as second, dot first, and cost can be located as second, dot second. So this is x-axis, this is y-axis, this is the cost itself. This is how you can see this. Okay. Now what is this? What is this you have written, Siddharth? What is this? I don't understand this. Now the thing is that the priority queue by default would sort according to the first element, but I don't want that. So this is a custom comparator function which would allow us, so that this would be ss.ss. Which is ss.ss? This is the cost. ss.ss means second dot second. Okay. So second dot second means we are sorting according on the basis of the cost. So the minimum cost would be at the top and the maximum cost would be at the bottom itself, whatever be the value or whatever be the contents of the priority queue. Good to go. We would be moving forward. Okay. Now the next thing is that it is the main logic. Okay. Main logic is that at first we are pushing the base one, top one, and then while the priority queue is not empty, priority queue dot top element, we are popping it, and then x-axis is the ff1 which I showed you in the last slide. This one ff1, second dot first is the second one. So Here SS means second, FF means first. Okay. Next thing is that if it is already visited, we won't be visiting it again. If it is not visited, it would come here. So we are making it one itself. And then what we are doing is, I would be showing you. The thing is that I would be moving in all the four directions. Here this side, this side, this side. So to move in all the four directions, there are two ways. One thing is that you do x plus 1, sorry, x plus 1 comma y, x comma y plus 1, and then x minus 1 comma y, and then x comma y minus 1. You can do all this. Okay, you need to type all this thing, but I am giving you an alternate to this. What is the alternate I would be showing you? I have declared an array known as dx. Okay, now what would the array contain? The array would contain 0 0 1 minus 1. Okay, and then in the second one I would be doing 1 minus 1 0 0. Okay, so now what I would be doing is, instead of adding and subtracting every time, which is error prone, I can simply add dxi to x plus dxi, x plus dx dot I, and y plus dx dot I itself. And this would be converted, and this one line of code would convert to this one. And I would be simply using a for loop of 0, a for loop of 4, and I would be iterating all the elements, and I would be adding to this one. And this is same as this long writing. Why this is important? Why I would make this? So thing is that many experienced programmers do this, and why it is important that iterating on the matrix on a graph problem is a common practice. You would come across this many times. Okay, so the thing is that you need to have this. This would make the code less error prone, and it would make your typing faster itself. So I would be using the same thing. X plus dxi, y plus dxi would be using with a for loop. I comma 0 comma 4. What is I comma 0 comma 4? For loop I is equals to 0, I is less than 4, and I plus plus. Same thing. Good to go. So now I am doing the same thing. So is valid x plus dxi with y plus dxy comma 4. Okay, 4 would check if it is on the boundary or not. If it is valid, then we are coming at this position. Now if the distance on the next node is greater than the distance on that node, then we are relaxing it. After relaxing, we are pushing it to the priority queue. This is what Dijkstra tells us. Okay. Now this is it. This is the code. Now I would be showing you the full code. Okay. This is the same as class prior, and this is dyx and dxy, and there are only two macros to make the code a little bit clean. SS is equals to second and FF is equals to first. Okay, so now the next thing is that we are checking on the boundary condition. Next we are making a visited array, the same thing which I showed is shift. Okay, and then what we are printing the distance of the boundary condition with an end line. Okay, so that's all. Let me check again. Okay. So am I clear till this point or not? Can I have a quick +1 in the chat? And I would be waiting for just 1 minute. And the thing is that it might be the case that you would need this implementation. That Siddharth, your implementation is very much good, and absolutely I can tell from my perspective that my implementation, if you use my kind of implementation, this is a kind of what I can tell. This implementation of Dijkstra can be bended to use it on different problems. That's why if you need this implementation, just go on LinkedIn, search Siddharth Hazra, ask me the implementation, and then I would provide you with the implementation and with this template. Okay, good to go. And the next thing is that dy and dx. This is okay. I don't find anyone who is encountering any doubts itself. So that's all for today. Thank you and have a nice day.